can, hello, hearty souls. Welcome back for really what's one of the more exciting afternoon sessions, which you will see the picture of this incredible aircraft that Carl is producing. And but it's not only an incredible aircraft design, and I'm speaking loudly to hopefully attract some attention from the lobby and the dining room, but it has application for a critical need in society, which is emergency response. And so we have a fireside chat opportunity with these two fine gentlemen, Dean Donovan of Diamond Stream Partners. He's a esteemed lead VC in the field of aviation, among other things, being a part owner of the largest airline in Mexico, among other things. But he is really in a small group of investors who are focused in this advanced air mobility space. So we're really honored to have him. And Carl Dietrich, Dr. Carl Dietrich, has a long resume, which I'll allow him to expand on a bit, but I know it has something to do with MIT, and I know it has something to do with early stage work, and among other things, the first flying car, if I understand correctly. So with that as a lead-in, I would pass it to you two to carry on, and I'm going to, when you tell me, I'll switch the slide, or you can...
I'll tell you right now. Go ahead, switch the slide.
Okay, good. So then this is the thing that I'm so excited about.
So, Carl, I might have to call you Doctor instead of Carl now. Hey, so before we get into your background and your story, what the heck is this thing?
Yeah, so this is a single person, what we call a standing tail sitter configured biplane eVTOL aircraft. It is designed for first response missions. So the purpose of this aircraft is to enable one paramedic or one first responder to get to the scene of rural emergencies as quickly as possible. That's the goal of this aircraft, and that drove literally everything about the design of this aircraft.
And Carl, I have a need for speed. Can you help me in that regard?
We can. We expect this to be the fastest eVTOL in the world by a pretty hefty margin. This vehicle is capable of doing 250 knots without breaking a sweat.
That's pretty amazing. So I can't wait to fly in one of these things. But let's take a step back before we get too far into this, and let's just hear a little bit about your background, kind of your previous venture, and how that brought you here, because I think that would be very interesting for anyone who's following the space, or anyone who's frankly trying to think about doing something in advanced air mobility.
Sure. So like many in this industry, I was a kid who was fascinated with airplanes. Started saving up for my pilot's license when I was 8 years old. Worked as an assistant mechanic at our local airport up at Noss Field in Novato. Got my ticket in high school. Went to MIT to study aerospace engineering. Promptly ran out of time and money. Stopped flying, and have only been periodically current since then. But in 2006, I was wrapping up my PhD program, and I had been working in the background a business plan for a company called Terrafugia. And Terrafugia was founded in response to the emergence of the sport pilot light sport aircraft rule in 2004. And we thought that we could thread the needle and make a personal use aircraft that could fold up its wings in 30 seconds with the push of a button, drive down the road, and park in your garage. And this was in the days before Uber. So it actually addressed the largest obstacles to the more widespread use of general aviation, according to pilots. So we thought, well, if we can get this into this new category that bypasses the traditional FAA certification process, and there's a bunch of good reasons that we wanted to do that, that had nothing to do with safety, that had to do with what we call prescriptive rule language, and we'll come back to this theme later, that there was an avenue to bring a product to market that, that could potentially address these problems, enhance the level of safety, enhance the level of convenience of general aviation.
And what were the obstacles that the pilots felt? Like, why turn it into a flying car? Why, what would be the advantage for GA pilots versus, say, something like Icon, which was also in that category, right?
Yeah, the transition was targeting a different customer than Icon. So Icon was looking for the adventure flyer, the true sport pilot. We were looking for the weekend getaway, the retiree couple that wanted to use their aircraft for the 2 or 3 day jaunt, to go around and to know that they're not going to get stuck anywhere. They can get home, they can drive when they don't want to fly, or if the weather is dodgy, or if there's just a front coming through, they could land, fold up the wings, drive, keep going on their trip. The aircraft used the Rotax 912 engine, which ran on automotive gasoline, so it was less expensive to operate, only burned about 5 gallons per hour, so it was very inexpensive from a DOC perspective. So it was a nice package. It had a safety cage, crumple zones, airbags, ballistic parachute system. It had a whole host of very modern safety features in the GA, in a GA product. The problem was it cost too much, and that was really the killer for the program in the end. But we went down the path. We built the technology. We demoed it at Oshkosh in 2013 and showed that it worked. We went around looking for capital to try to put it into production, but nobody was investing in general aviation at that time, except for China. And so the next year I started traveling overseas and wound up taking some Chinese venture investment, and then eventually taking investment from one of the largest automotive conglomerates, the Zhejiang Geely Holding Group, which owns Geely cars. They purchased Volvo in 2010, Lotus, London Taxi, Proton, a bunch of other global brands. Our theory was that if we were going to be able to bring this product to market successfully, we needed to significantly reduce the cost of production. And so we were thinking, well, if we can leverage the Chinese automotive supply chain, that's a great way of driving down the cost of production,
right,
of the aircraft. And so we spent a number of years post-acquisition. So Geely wound up buying our company, and we spent a number of years post-acquisition focused on trying to drive down the cost of production. In the meantime, we were also developing new concepts for the emerging air taxi eVTOL market in parallel with this. And so I was running those operations in parallel with the cost reduction program that was going on at that time.
But describe Oshkosh, because it's actually quite an amazing story between the hype that can happen when an aviation concept actually works and comes out, and then the challenges that you face afterwards.
Yeah, I mean, Oshkosh was always sort of the big external driver for progress every year. You go back to that show, and we'd go back and we'd see some of our customers, we'd see some of our investors in person at that show off the progress that we made over the past year, and it was really always the marker of our evolution. And 2013,
it still is for many
GA companies. That's where you launch the big products. The new stuff comes out at Oshkosh. So 2013 came along, and this had been the time that we were dreaming of since 2006 when we founded the company. So we've been working on it for 7 years. Finally got it to the point where we were able to demo it live. We did the whole thing. We drove it out of our booth, pulled it out onto the runway, unfolded the wings in 30 seconds, got out, did a quick walk around, got back in, started up, taxied it out, took off, flew around, did some figure eights and what have you, landed, taxied back in, folded up the wings in front of the crowd, drove around. When you land, you didn't even have to get out of the aircraft to fold it up and start it up again. So it was.
And how many people How many people were there typically? So
We did that demo in front of about 100,000 people. So
100,000
it was, yeah, it was, you know, and there you can still Google or on YouTube, you can see the videos. We put out some videos of the live demos.
It's almost like a 1930s barnstorming event. I mean, that's what it sounds like.
Yeah, no, it totally is. It was a blast. It was amazing. It was one of those experiences that, you know, I'll always look back on and say that was an amazing experience to have the opportunity to do that and to show what we were able to build. That said, you know, what happened in the wake of that was almost more interesting and even more formative. The struggle of finding the capital to take from the concept to production, and then the realization that, hey, this thing actually just costs too much to produce. And even with a Chinese automotive parent company, we could not drive the cost of production down to the point where it made sense and that's why you can't go out and buy one today, which in many ways is kind of tragic because it really would have set the bar for safety in general aviation.
And what other lessons did you take out of that? I mean, I think it's an amazing story about the ability to engineer something. And actually, from our perspective, it's not an uncommon story because typically the aerospace engineering piece is 2 steps removed, unlike in a car where it's usually 1 step removed from actual mass usage. But what were some of the other, and so it's hard to get the insight into the economics if you're actually designing the vehicle. But what were some of the other things that you took away from building out Terrafugio that I know you've built into Jump?
Yeah, so a lot of the learnings actually came not only from the transition program and the sensitivity on the cost side, but also we spent quite a few years looking at the emerging eVTOL space. So we participated in a DARPA program for a VTOL aircraft in 2010, 2011 timeframe. We then developed a concept for a personal eVTOL in the form of TFX. We flew some subscales, did some full-scale component integration testing, battery testing. We then started doing eVTOL air taxi concepts, and we had a concept that had a detachable pod that could either be a passenger pod or a cargo pod to address these market opportunities that a lot of the industry is going after right now, and a lot of that work has part of it was sunsetted and part of it made its way into another Geely company that is continuing to pursue, that's now called Aero, continuing to pursue.
Very original.
Right. eVTOL air taxi concepts in China. And I would say, you know, in 2019, when I decided it was time to leave Terrafugio, and I spent a while thinking about, okay, I believe I have some unique insights into this space from a decade plus of struggling to do a startup that's trying to do something novel, and all the challenges that are associated with that. And I knew, of course, that, you know, as a startup, I don't want to be throwing my hat into the ring and doing the same thing that everybody else is doing. That's not a good way, especially unless you're really, I mean, if you're the Joby of the world, or you know, in that first, the leaders of the pack, that's great. But in the process of looking at both the technology and the business models, really kind of hit on some of the major obstacles to the advent of this advanced air mobility space, and determining that, hey, that a startup is not actually the best way of addressing those obstacles. In particular, you've got regulatory challenges, the path to certification. At that time, we were all using Part 23 Amendment 64 as the cert basis, plus some additional special conditions. But beyond the regulatory challenges, we've got the infrastructure challenges, that a lot of which have been talked about in previous panels, and we've got public acceptance challenges that have also been talked about now in previous panels. And that really led me to the conclusion that, hey, why don't we do something new that really tackled those barriers head on? starting with public acceptance. How do we start at a high level with something that, what is a concept that you explain it to anyone and they're gonna say, yeah, that's a good thing to do with this technology. And that's where we hit on this, this model of using eVTOL technology to help first responders get to the scene of rural emergencies as quickly as possible. You're addressing an underserved community, you're using new technology, you're not flying over densely populated areas, you're not even doing a Part 135 operation, you're operating under Part 91. With the new Mosaic rulemaking, we don't even necessarily have to, assuming it moves forward, this would be a light sport aircraft. This would bypass the traditional certification. Even if it wasn't, it would be a level 1 cert project instead of a level 2 cert project. So the barriers to entry are significantly lower, and from an infrastructure perspective, you're deploying this out of a non-towered GA airport that, as was mentioned before, you know, you can put some solar panels on the roof of a little T-hangar, charge a Ford F-150 Lightning pickup truck that tows a trailer behind it to go pick up the aircraft from wherever it goes, and there you go. You've got the entire operation basically as a prepackaged nutshell. You don't have to put in any new power grid infrastructure or anything like that, because the frequency of flights is relatively low in this. And that's one of the big differences from an operational perspective of this mission compared to air taxi.
So tell us a little bit about the problem. What is the rural medical first responder problem that you're trying to solve here?
Yeah, today in the United States, the average rural first response time is about 14 and a half minutes. And you contrast that with what we enjoy in urban and suburban areas, which it's about 7.5 to 8 minutes. Now you would think, well, what's the difference, 7.5 minutes versus 15 minutes? And it turns out that for medical conditions where you lose the flow of oxygen to your brain, so that's cardiac arrest, stroke, even some allergic reactions, things like that, if you get the flow of oxygen cut off to your brain, you are on the clock. And this is one of the reasons why today in the first response industry, ambulance companies that may be on contract to provide those first response services are typically on contract to get to a certain percentage of their calls, typically 70, 80% of their calls, within 8 minutes. Because it really comes back to the physiology of time-critical emergencies. So the key figure of merit that drove the design of this aircraft is how far can you go in 8 minutes? That's really the big driver for it. It's not dollars per passenger mile, or any of the traditional metrics of aviation, because the farther I can go in 8 minutes, the more lives I can save with that one asset. And that improves the return on asset, return on investment, et cetera, et cetera.
And how many lives do you think you could save a year if you deployed this nationwide?
If you had this deployed nationwide, it would approach about 100,000 lives per year saved. It would also help save the healthcare industry about $4.2 billion a year. And there are additional market opportunities that are opened because this vehicle can do things that don't make economic sense today to do with a team of 2 people in an ambulance. For instance, so there are 29,000 fire departments around the country. Fire department typically does most of the first response calls, medical first response calls. About 18,000 of those 29,000 are volunteer fire departments, right? These are little rural areas that are not densely enough populated to support paying full-time people to stay on staff, right? And why not? Well, because in a fire truck or an ambulance, you can only go so far in that you can only cover so much area in that critical window of time. Now, if we bring a technology to market that dramatically expands that range of coverage, the underlying economics of first response business fundamentally change. And that's the opportunity that we're recognizing, and that we're saying, hey, this could really move the needle. It could make financial sense to put an airplane that costs more than an ambulance, plus a team of 2 full-time professionals on duty in a rural location where it does not make sense to have an ambulance with a team of 2 professionals today. That is a revolution in first response. And that's one of the things that we're really excited about, and that's one of the reasons that we've been able to attract interest from some big first response companies, like Falk is our launch partner on that. So.
And how do the fire departments feel about this when you bring this to them?
This is so different. This is, to some of the points that were made before, it's very interesting because generally speaking, first responders are not impressed by computer graphics, right? They're like, yeah, right, okay. Like, come back to me when you've got something that I can kick the tires on, basically, right? That is the typical response, and that's totally understandable, right? So one of the challenges that we have is helping people understand that, yes, this is computer graphics, but hey, we've been flying subscale aircraft. We know that this is physically possible. There's nothing about this that is a huge technology stretch based on stuff that we've done before, based on stuff that other companies have done. The technology piece, it's time and money to mature it, right? That's really what it comes down to. But from an overall risk perspective, it's time and money. It's time and money. And the thing that, as an entrepreneur, I look at and I say, well, how much time and money? How long will it take, right? And then what is the prize at the end of the tunnel, right? And when we try to quantify that, what we did was we went out to rural Americans who know that this is a problem. By the way, if you live in rural America, you know that it's going to take a long time to get help if you need it. We surveyed over 500 rural Americans and described the type of service that we're providing, which, by the way, doesn't transport a patient. This just gets help to them. That's all we're doing, right? Just getting to them faster. And basically said, how would you value this? What would you be willing to pay anything? If so, what would you be willing to pay? And so with that data, we were able to determine, yes, in fact, 80% of the rural population in America would pay something for this, which suggests that in the long run, this type of service will just be part of the rural tax basis, right? So the question is, okay, between now and then, how do we get from where we are today, where it's computer graphics on a wall, and some ideas in some small-scale vehicles and some Air Force contracts and stuff like that, but a relatively small nugget of something, and bridge it to when it's just the standard of care in rural America, and that's just how it. So how do we get from here to there?
That's always the challenge. It strikes me that there's two parts where the government's played a role. One of which I'd love to hear about next, but both how do you get the engineering done, but then also how do you generate public acceptance for this? Because rural people are not necessarily. They don't like the government to impose things on them. They also tend to be fairly frugal because they tend to be in more impoverished parts of the country. We'll get to that in a second. But what role has the Defense Department and the government played in getting this off the ground and supporting this idea? And how did you arrange that?
Yeah, the involvement of the Air Force Agility Prime program has been huge. That program didn't exist when we were doing Terra Fugia. And it is incredibly impactful.
This was really Will Roper that.
Will Roper, yeah, Nate Diller, the dash is still there. Like there's a crew there that really were champions of the Air Force getting involved with advanced air mobility, and Joby has benefited, other Archers have benefited, a lot of the companies in the space have benefited. We're fortunate to be.
I was up in the up in the Air Force Base in the Central Valley the other day, and we're rolling the Elroy aircraft up inside a C-130, which is just, it was the old aviation and the new aviation at the same time, sort of this tiny little aircraft, which looks pretty big when you stand next to it, but when you put it next to a C-130, it looks microscopic. Yeah. So, but anyway, keep going.
No. Their involvement, so we won a couple of Phase 1 STTRs, we rolled those into Phase 2s, and now most recently, we were awarded a tactical financing increase, which is going to be funding the first full-scale build of this. So we're now moving from subscale to full scale. And that's huge, to know that the Air Force is interested enough to put in some real money and help us make this thing a reality. Right now, as you can imagine, that a product that is ideal for first responders has a lot of potential DoD utility as well. We've talked about missions like downed pilot extraction, medical, field medic, same mission, but on the defense context, rapid resupply, these sorts of things. There's a lot of potential use cases, but the big thing that we're really focused on is developing the aircraft and the entire concept of operations for rapid deployment, rapid and safe deployment.
And would they put these things in C-130s and ship them off? And
You could. This thing will fit on the back of a standard flatbed trailer, and you can drive it down the road, and it's not a wide load or anything like that. So you can. It's very
And the financial support from the government must be very helpful at a time where it's extremely difficult to raise capital.
Absolutely. I mean, I love being able to give a pitch and show, hey, yeah, we've got revenue, and it's been actually going up really nicely. We've been able to, that's huge. We were never able to do that at Terrafugia, right? We had one-off DARPA contract that was, fell in our lap, but to have consistent support that enables, and we have to show progress. We have deliverables that we have to meet. So it's great on multiple fronts. It's just in the same way that Oshkosh was a fantastic external motivator. We could say we're all working towards that. That is a hard deadline. It is immovable. Same thing with an Air Force contract. So it's actually a very powerful
discipline to the
absolutely,
business.
Absolutely. There's you deliver.
And does that help scale? I mean, it sounds like it's been very helpful in the early stages. Will that help scale through the later stages? Do you think that's true? Or?
Well, we'll see. The Air Force likes to see these dual-use technologies, and so they really want to see the commercial use case evolve, because they don't want to foot the entire bill for the whole program. But given the utility of this type of platform and how it's complementary to other concepts that they're also backing, I think that there's a good shot that this could result in a long-term relationship.
Right, selling units or maybe a StratFi contract or something like that.
Yeah,
Great.
absolutely.
And let's switch gears for a second onto the public side. So you and I have talked about some of the challenges in trying to develop a new aircraft just with the airspace. Why don't you talk a little bit about that?
So, are you talking about the local airspace?
Yeah.
Okay, yeah.
The NIMBYism.
Yes, yeah. So, Jump Aero is headquartered in the North Bay. So we're in Petaluma, and one of the reasons that we landed there is that, of course, the airspace is a lot more open than it is down in the South Bay. And so I actually learned to fly in that area, so I was very familiar with it. And actually, we could potentially start operating locally in Marin and southern Sonoma County, based out of Noss Field. So it's an area where we could actually start not only doing our test flying, but also our actual first operations under the same area that we were doing test flying. So that is a major benefit. Now, one of the challenges of working in this area, and this is actually something that I think you guys do a great job of addressing down here locally, is that up in Marin and Sonoma, nobody likes drones. So there are lots of rules that prohibit you from flying smaller aircraft. So while I can probably fly a full-scale one of those, I'm having to drive far away to fly my little subscale aircraft that, arguably are much less risky to do early test flying than a 3,000-pound full-scale aircraft.
DGI has put us all in the penalty box, unfortunately.
Yeah, something like that. Yeah, so it is an interesting situation where we wind up needing to travel farther for our little things than for our big things. So we'll see how things evolve, but that is one of the practical challenges that we've encountered.
And as you mature the concept, what kind of public interaction do you see beyond just selling to fire departments? Is this something that you're looking to cooperate with state governments on, the federal government on, in terms of providing emergency response?
Yeah, absolutely. We actually just announced earlier this week an MOU with the state of Utah, and a shout out to Clint and the Utah DOT. Thanks, Clint. Really excited about that Utah on the state level. So first response in Utah is generally handled by the sheriff of each county. But it turns out Utah actually has a few counties where over 50% of the population live in what they call ambulance deserts. So these are areas where it takes more than 25 minutes to get help if you call 911. So it's a great area for us to go. And of course, with all the national parks and things like that, you've got hikers that can get into trouble, et cetera, et cetera. So this is a fantastic area for us to go and demonstrate the potential of this technology. So the MOU with Utah is to work with them to figure out how many of our aircraft it would take to cover the entire state of Utah with 8-minute first response. And that's really exciting because, nobody's thought like that before about the possibility of covering a whole state with 8-minute first response. You can only do that with aviation, right?
Yeah, it's sort of a systematic attention to healthcare for entire populations instead of sort of localized reactions. That's very exciting. Okay, now we're going to get to the part that everybody wants to know. Are you going to be able to buy one of these and fly it yourself?
So,
wait, quick poll. Who wants to fly one of these things? Come on. It's the fastest. All right. So you got at least 30 sales right here.
Yeah, it's your Iron Man suit, or your Superman suit right there. Like you take off standing up and you're flying prone and landing standing up.
The
again.
Iron Man suit costs extra though, right?
Right. So so look, our goal is to get it out there and start saving lives as quickly as possible. And I'm sure there are going to be a lot of other uses for this type of technology, but in our view, the right place to start is with these missions that are just across the board going to have widespread public acceptance. Yeah. I think, who was it who mentioned, babies and grandmas before? Yes, thank you.
All right, Matt.
I couldn't agree more. Like we get some really positive attention, positive feedback, and get that association, that positive association with advanced air mobility in general. That's what we need as an industry, and that's what we want to do, what we want to help catalyze at Jump Aero.
Super exciting. All right, does anybody have any questions for Carl? I could ask questions for another half hour, but Matt, go for it.
Yeah, so the question was what interaction have we had with some of the subscription air ambulance services? So we've been in contact with a couple of subscription air ambulance services. We've got NDAs in place with them right now, so we're not able to talk too much about it. But we have reached out to air ambulance services. This is, even for those companies, this is a different way of using the aircraft than what they do today. So it is still incumbent upon us as the developer of the novel concept of operations to de-risk the whole thing, to figure out how it's going to work and to de-risk it. And what we want to do right now is just be transparent with those potential customers about how we're doing. And we believe we have a concept as to how long it will take to safely deploy the aircraft. But until we actually get out there with full-scale vehicle and are doing these simulated deployments, we won't know for sure how long it will take to get the wheels off the ground. But for reference, a typical helicopter air ambulance takes about 3 to 5 minutes to spool up on a call. Our goal is to, from call to wheels off the ground, less than 1 minute. That's our target. And have that be a safe, methodical departure. It's just you're not doing that much. It doesn't take that much time, right? So there's a lot that has to go into both the design of the aircraft and the design of the operation itself to enable that to be a non-rushed process, to just be, that's just what you do, and it just doesn't take that much time. But it is one of the true enablers of this mission. That's something that I like to emphasize, is that many people have recognized the potential of an all-electric aircraft with distributed electric propulsion to potentially be more robust, have lower direct operating costs, to potentially be less noisy, all these sorts of things. But one of the things that we really hit on is you can also go to full power instantly, and you really can't do that with a thermal engine, right? Well, you can, but your engine, you're going to wear out your seals, you're going to thermally shock your engine, right? So you're not going to do it that much. You won't be able to afford it. So when the military needs to keep aircraft on standby, they keep the engines running, right, to keep the hot section hot. And but that certainly doesn't make sense for an emergency response vehicle. The economics of that are horrible. With an all-electric, you can get that rapid response because you can go from completely off to full power instantly.
And presumably this would be a complement for them. So maybe a distribution channel for you and a new product for them.
Absolutely. It is a greenfield market opportunity for those companies. They already know how to operate aircraft. In this case, it's not even a Part 135 operation, so the barriers are lower from a regulatory perspective. The challenge is that it is a novel operation, and there are unknowns associated with novel operations. So we'll see. But I'm optimistic that we'll make some inroads into that with those operators of aircraft.
Hey, if you knew exactly how it was going to go, it wouldn't be an adventure, right?
Exactly.
Any other questions before we finish up? Yes.
Yeah, I have a question on the automation versus the operation of the person that's inside. So have you perceived how much of it is going to be automated? You have a geographic point you're trying to get to. But then when you land, maybe there's a car park there or something. So how's that perceived to be working?
Yeah, our aircraft is totally piloted. It is not autonomous. It has a fly-by-wire control system with simplified flight controls, so it is envelope protected. But it is, and the reason that it is not autonomous is, well, there's a large number of both regulatory and primarily regulatory challenges associated with implementing an autonomous aircraft that's carrying a person today. My wife actually works a lot in autonomy. She works with both X-Wing and AUVSI and a number of other companies in autonomy. And I am confident that a path to certification will be determined. I don't know how long it will take. And what we want to do is not compound risk, right? We want all of our risk to be associated with a value. Right, the risk of this aircraft is all about, there is a novel configuration of the aircraft, that there is some technical risk associated with that, but not too bad. The key thing is you've got a new business model, you've got a greenfield market, and a new concept of operations of an aircraft. So we concentrate the risk there, and let's not take on unnecessary risk. In this case, it doesn't need to be autonomous. We can do things with advisory software, think of like a ForeFlight type app for this mission that can guide you in through a virtual highway in the sky, but it's all still hand flown. And then when you get to your landing zone, one of the things that you see, there's a big belly window on this aircraft. So when that belly window enables very, very steep approaches into unimproved landing zones and gives you tremendous situational awareness. In fact, I would argue that there is no aircraft out there that has situational awareness of an unimproved landing zone that is better than this. It's like you're right up against a glass window, able to look straight down on the landing zone. And so if there's a car parked where it's recommending that you land, you don't land there and you fly somewhere else. And but the pilot makes those calls on the fly. So
Hey, and a lot of these paths have been trod or are being trod right now by the light drone and sort of smaller scale drone industry. So by the time you get there, this will not be the first time people have been solving this problem, I think it'll be pretty well tested. So
Absolutely. We do not employ the same sort of vertical strategy on the supply chain side or on the tech side as some of the other big eVTOL companies, because our goal is to get this technology out there as quickly as possible and show that we can start saving lives with it, right? We don't need to own everything. We need to get it out there. We need to have the impact.
hey, that's the voice of experience right there and the voice of practicality. Thank you so much, Carl. This has been a
Thank you.
great few minutes.
Thank you. So fascinating.